Hello, and welcome to Quinn Design Consultancy, the value engineering service for architects, engineers, and developers seeking to leave their mark on the industry by creating a legacy of efficient, cost-effective projects with exceptional quality. In this case study, we're going to take a look at an unconventional building called a TFB structure. This system ended up cutting 63% off the initial budget price and put the construction streaks ahead of its original schedule. What's more, we managed to do this without impacting the design or compromising the quality. So why haven't you heard about it? Well, for one, it's not your standard building solution. Today, you're going to discover what the system is, how it accelerated the schedule by over an entire year, and the single most important reason why it's so incredibly cost-effective. So with that said, let's take a look at the $6 million reason you have to know what a TFB is. What is universally true about almost every construction project in the world? It will inevitably go through some sort of budget difficulty during its lifetime, and then you'll be faced with cutbacks in design, compromising quality, or even project cancellation. The project I'm about to discuss was no different. It was a polypropylene production facility. This case study focuses on just two of their buildings, a 1,450 meter squared workshop and warehouse, and a 1,100 meter squared chemical storage building. When trying to design a facility on a tight budget, you try and present the most economical design possible. A standard cost-effective design is a pre-engineered metal building. Why? Well, that is because pre-engineered buildings are seen as the go-to solution for cost-effective engineering. They use tapered columns to obtain optimal strength and span whilst using the least amount of steel. Components are standardized and pre-engineered to deliver savings in design, manufacturing, and site erection. Using tapered columns, you get as much as 30% reduction in steel weight and the equivalent reduction in construction costs. Plus, construction time can be reduced by up to 50%. So the buildings were designed and sent out for pricing as pre-engineered structures. The average bid price came in at $9.5 million with a scheduled duration of 18 months. But with the project verging on the edge of financial viability, all disciplines had to look at ways to reduce the total installed cost. How do you do that when you've already proposed the most economical solution you're aware of? Well, a cost-cutting exercise typically involves cheaper materials of construction, reducing the building size, or some other sort of concession. However, the client wasn't prepared to compromise the functionality of the facility in this way. So we were left with a bit of conundrum. How do you meet the brief, maintain the design standards, and still reduce the total installed cost? I'm certain you've been in this situation before. Well, in this case study, I'll show you how my investigations led me to the single most impressive building system I'd seen in the past 25 years. This system was so effective that it would help us achieve a multi-million-dollar savings and radically accelerate the construction schedule. The system I'm about to reveal came to my attention because of something I'd recently seen. I'd just driven past an unrelated construction site. The site had been cleared and they had just finished the foundations. When I drove past just 2 weeks later, I was surprised to find that the entire superstructure was already complete. What type of structure could possibly be erected so quickly, and more importantly, was the quality up to scratch? I discovered it was a TFB building. So what is a TFB structure? It's a tensioned fabric building. Normally any mention of a fabric building would raise immediate concerns. That is because most TFB manufacturers target a different market where low-cost structures outweigh long-term durability and quality. Here are the reasons for concern. They tend to be used as cheap temporary facilities or low-cost storage buildings. Their membranes can be easily damaged, and the structure doesn't stand up well to high wind loads, and they're unsuitable for use in heavy-duty industrial environments. For the most part, that's entirely true. But I found out that there's one manufacturer whose product defied these preconceived notions. You see, I couldn't put forward a low-quality building system just because it was cheap. Not only would it fail to meet the client's expectations, but the reputation of the engineering firm I was working for was at stake too. They had been on Ethisphere Institute's list of world's most ethical companies for 12 consecutive years and couldn't afford any fly-by-night solutions. In contrast to the everyday TFB structures, the manufacturer I discovered had erected over 12,000 structures globally in almost every industry sector, from fabrication and manufacturing, oil and gas processing plants, military installations, and even correctional facilities, through to hospitality buildings, retail, commerce, education, and recreation. Plus, they'd been installed in the most extreme climatic conditions in the world, from the Arctic, experiencing minus 60 degrees Celsius, to the harsh deserts of the Middle East, where the mercury has risen past 50 degrees Celsius. Their structures had even withstood 100-mile-per-hour winds of Hurricane Katrina. So how is this manufacturer different? Like most, they use a tension fabric membrane. However, the key difference is a lightweight but robust, deep-profile aluminium structural framework. This makes it incredibly light, quick and easy to install, and formulates the basis of another unexpected benefit. The exceptionally lightweight superstructure completely eliminates the requirement for piles, and therefore expensive pile caps, excavation, and piling rigs. If desired, they can actually just be secured with ground anchors. They offer clear-span open layouts of up to 160 foot, which can be extended to 200 foot with lattice beams. Further, they use an extremely tough interwoven ripstop and puncture-resistant performance membrane with high tensile and tear strength, which can be integrated with a proprietary insulated system. Windows and doors can be adapted to suit almost every purpose, accommodating equipment as large as Caterpillar 797s to helicopters and even aircraft. Not only is it more economical, but it lowers OPEX costs too. Here's why. The aluminium structure does not rust, plus it does not need any additional surface coatings, therefore does not require ongoing inspection or maintenance. As the fabric is non-conductive, the building will remain cooler on hot summer days and warmer on cooler days, providing lower heating and cooling costs. Additionally, translucent panels will allow natural light to permeate into the building, further offsetting lighting and energy costs. But there is another differentiator alongside the simplified foundations that makes this sort of structure so incredibly efficient: its speed of erection. An insulated structure can be installed up to 750 square foot per day, and an uninsulated structure from between 1,500 to 2,000 square foot per day. This sets it apart from every other rigid frame metal-clad structure. So who is this manufacturer? Their name is Sprung Structures. You may be wondering if this is just marketing hype. How does it stand up to real-world conditions? How can you protect the surface of the walls in higher impact zones? and can it accommodate heavy-duty activities? Well, there's nothing quite as reassuring as seeing the structure firsthand. Here's what I discovered when I went to visit an operating manufacturing and fabrication facility. There was a hub of activity, forklift trucks driving about, an overhead gantry crane, and even welding procedures taking place, all with no limitations whatsoever imposed by the fabric building itself. In areas of high impact, where extra durability is required, a hard wall protective shell can be added. Even if it is damaged, it is easy and inexpensive to mend with a simple repair kit. So it's not just a tent. When I presented my research to the engineering firm, they were more than satisfied that not only did it meet the client's demanding criteria, but the high engineering standards they expected of themselves too. Therefore, I was permitted to submit a second budget inquiry based on a sprung TFB structure. Let's analyze the results. When we received the contractor's prices, the savings were far greater than we could have ever anticipated. The original price of a pre-engineered building was $9.5 million, while the new price came in at an incredible $3.5 million. That's a staggering $6 million off the total installed price. And the reduced complexity of the foundations, combined with the rapid erection process, reduced the schedule by an entire year. But there was another, and perhaps even more compelling reason to use the structure. We all know that safety is one of the industry's #1 priorities. The accelerated schedule literally eliminated thousands of man-hours on site, which meant reduced construction risk and a greatly improved execution safety plan. So the project readily adopted this new method of construction, giving the engineering firm an unprecedented value engineering advantage. What you see here is a letter of recognition for my capital discipline contributions. In summary, on just 2 buildings, I managed to save $6 million by proposing a more affordable solution, complied with all the original performance requirements, took over 1 year off the construction schedule, which turned out to be an unbelievable 75% acceleration, eliminated thousands of hours of construction risk, contributing to a safer project for all, provided a design that lowered the OPEX costs and improved the environmental performance of the building, and most importantly, provided all these advantages without compromising the quality or functionality of the building. It was simply an extremely cost-effective solution with an incredibly efficient method of construction. All the benefits plus $6 million savings. Cheaper, safer, quicker, and better. For more information on this product, or to learn about our other incredible value engineering solutions, please go to www.quindc.com or email at info@quindc.com. Thank you for your time, and goodbye for now.